So at some point of your life, you've heard the word average to describe some kind of situation. So when we have a bunch of numbers or some kind of data on a population, you hear this word average to try to describe some key piece of information for that group. So you might have heard the average height for males, the average weight for males, the average weight in this age range, the average age of a population based on whatever country they're in. That word is trying to give you some kind of measure to tell you what a typical individual looks like in that population. So we actually have 3 different types of measures of average. And those are going to be the mean, the median, and the mode. Okay. So typically when you hear the word average, what people tend to think of in their mind is you add all of the values together, divide by how many pieces of information you have. So if you're trying to calculate your average test score, you would add up all your tests, divide by the number of tests that you took. This is what you typically think of, and it's what we refer to as the mean. So the mean is found by adding all the data values up, then you divide by the number of pieces of data. The way I like to remember this is the mean is the meanest. It is the most time consuming. It takes a lot of effort to go through. So that's one way you can remember it. Now, the median is really, you can think of it just in the English word. If you think of median, you might think of the median in a highway. It's that middle barrier that separates right down the highway in the middle. And that's exactly what the median does for the average. So the median is the middle value in the ordered data. And then our third one, the mode, you can remember is it's the value that appears most often. So mode, most. Same number of letters, same 2 starting letters. So that's the second one. Okay. So the mean has a set approach. For the mode, you're looking for the value that appears most often. Remember talking about that modal class. But it is possible that you might have multiple modes or you might have no mode. So in the case that no number repeats or every single data value appears the same amount as others, there's nothing unique to it. So in this case, then there is no mode. And then it's possible if the most amount of data appears 7 times and you have 2 data values or even 3 data values that appear 7 times, you can have multiple modes. Okay. Now moving on to the median, that key piece of information, the median divides the highway in 2. You're looking for the middle value, but specifically it has to be ordered. So you either want to put the numbers smallest to largest, largest to smallest, but it has to be the ordered data for you to find the middle value. So to find the median, we're going to do a few things. First, we're going to list the numbers in order. So again, you can do small to large, or you can do the other way. Really doesn't matter what you want. Personal preference. Okay. The problem is based on how many data values you have, you might not have one directly in the middle. But if there's an odd number of values, then the median is directly in the middle. So to just kind of show you with a nice example, say your data in order is 1, 2, 3, 4, 5. Then there is a number that's directly in the middle because there's 2 on either side of it. However, if you have an even amount of data, so 1, 2, 3, 4, there's no middle. You have 2 numbers that fall in the middle because they have 1 on each side. So in this case, if there is an even number of data values, the median is actually the mean of the 2 in the middle. Or, tie it into what we called it before, it's the midpoint of these 2 values. So if you want the mean, you would add the 2 numbers in the middle together. And since it's dealing with 2 values, you divide it by 2. So in this case, that would be 5 over 2 or 2.5. So 2.5 is the mean of the middle two numbers, or it's the midpoint of 2 and 3. Okay. So there's one last thing we're going to introduce in this section, but we're going to actually talk about that in a future one when we go through working with how widespread your data is. And this is the range. So the range is the difference in the smallest and largest value of your data. Okay. So let's try a few examples. We're going to start with a survey. So on a survey, 7 students reported how many minutes it takes them to travel to school. Here are their responses. First thing we want to do is we want to find the mean travel time, and we're going to round to the nearest tenth. So tenth means 1 decimal. Okay. So again, I need to add all of these values together, and then I want to divide it by the number of data points I have. And in this case, they tell us that there are 7 students. If they didn't, you'd have to count 1, 2, 3, 4, 5, 6, 7. So I would have to take that total and divide it by 7. So adding these all up, we'd have 6 plus 9 plus 9 plus 7 plus 9 plus 4 plus 6. And then once we add it all together, we're going to go ahead and divide it by 7 because that's how many data values. Be very careful when you enter this into your calculator, especially if you're using your phone. Add them all together and press enter. So if I add all the values together, that gives us a sum of 50. And then we divide it by 7. Okay? So all the values added up is 50. When you divide it by 7 and round it, the answer is 7.1. Okay? So what would happen, one thing you have to get really good at is really just kind of asking yourself, does this make sense? So in this case, we're saying the average time for a student to travel to school was 7.1. And that seems reasonable based on these responses. If you found your mean was 47.8, that does not even remotely look close to any of these values. There's no way the average travel time is 47.8 when no student took over 9 minutes. So if you get something like that, it's very likely you had a calculator input. Because what tends to happen is if you add all of these up and then press the divide by, because of your order of operations, it's just doing division on the 6 over 7 and then adding those numbers in. So be very conscious and ask yourself, does this make sense? Is this a good representation for my population? Because it should be what the average student is doing, okay? Now for the other two, we're gonna start by finding the mode travel time. So if I go look back at my population, the number 9 is appearing 3 times, and the only other number that repeats is 6, but that only appears twice. So the number that appears the most is 9. So this means our mode is exactly 9. Okay. Now for the median, again, we're looking for the middle value, and this is what tends to go wrong. You have your list right here. You go ahead and say the median is 7 because there are 3 data values on either side. But that is not what we want to do. What I need to do is put this data in order. Again, smallest to largest or largest to smallest. Completely up to you what you want to do. So we're going to start, our smallest data value is 4. Then we have 6 as the next value. So you can leave some spaces. You can also put commas in between, especially if you've got like a couple digit numbers. This way you don't get anything confused. The next number is 7. And then I've got 3 9s after that. So 9, 9, and finally a 9. So our data is in order. I want to find the middle value. If you have a lot going on, what we tend to do is just kind of cross off one on each end until you land to 1 or 2 values in the center. And in this case, it did happen to work out nicely that it was the number that was in the middle before, but it doesn't always do that. You always have to make sure it's in order. So in this case, our middle number is 7. That means our median is 7. And then this also is really helpful now that I have these data values in order. If I want to find the range, I'm going to take the difference in the smallest and largest values. So our range is going to be the bigger value minus the smaller. So our range in this case is 5. And again, this is going to be something that measures how spread out our data is, which we'll talk about in a future section. So let's try this other case, because really mean, median, or mean and mode, not going to change based on the number of problems. But what happens if we have an even number of data? We want to go ahead and try to figure out the median. So applying the same kind of problem, a group of 10 students from the same middle school have been asked to record how much time they spent this morning traveling from home to school. These are the results in minutes, and we want to find the median travel time. So again, I've got to put this in order. So my lowest value is 3, and I actually have 2 3s in this data. So I'm going to go ahead and cross those off as I use them. Next value is 4. Then after that, we've got an 8 and a 9. The more we do this, the more we can kind of cross off and do multiple at once. Next up, we have 111. Then after that, we have 2 12s. And then we've got finally a 13 and a 14. Okay. So just to check to make sure I've listed everything, I'm going to count that I have 10 pieces of information because it says 10 students. And indeed, I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces of information. So it's very simple or very easy to miss a number, so just be extra cautious. Now I want to find the middle number. So again, I'm going to kind of mark off 1 by 1 on each side until I get to the middle. And then once I've done that, now here I've landed with 2 numbers that are smack dab in the middle. So what I want is the midpoint or mean of these 2. So in this case, our median is we add these numbers together and divide by 2. 9 plus 11 is 20, divided by 2, which gives us a median of 10. Okay. So one special case based off this, if it's odd number of data values, it's much nicer because there is exactly a middle number. And then if it's an even number, you have a little bit more work to do. So let's try one more problem before we go into why we need all of these different types of averages. So this one tells us the scores on a test for a sample of 39 statistics students are summarized in the following table. We want to find the mean score and we want to round to 1 decimal place. So this table is a little bit deceiving because you only see these 3 scores of 70, 80, and 90. However, there are 39 students that took this test, and that's what this left-hand chart tells us. So if I do 8 plus 16, that's going to give us 24. Add another 15. Adding all of these together gives us those 39 students. Okay? So what this first row is actually telling us is there are 8 students that got a 90. So this represents that you have 90, 90, 90, 90, 90, 90. Let's see, that's 6, 7, 8 90s. So someone got a 90 8 times. What the second row tells us is that 16 students got an 80. And then this final row tells us 15 students got a 70. So instead of having to write all of that out and have 39 pieces of data, this chart has condensed it. So when I go to calculate the mean, I would have to add up the 90 8 times. But remember, the repeated addition can be condensed with multiplication. So there were 8 students that got a 90. That adds the 90s 8 times. Then there were 16 students that got an 80. So I would have to add 16 80s. And then finally, there were 15 students that got a 70. So we'd have to add 15 70s. And in total, there were 39 students, which again came from just summing the number of students column. So this is exactly how we count the mean. So again, do everything in the numerator first and then divide by 39. So if you plug this into your calculator, the top would add to 3,050. And then when you divide that by 39, this gives us 78.2 as our mean score. Okay. And again, this seems like a good representation. The mean score should definitely be a number between 70 and 90 because that's what our data falls in between. So it's got to be some average within there. And then just as kind of like a side note, in case you do look anything up about the mean, one thing we also do to represent it is we use a capital X with a bar on top of it. So if you see that notation, you're just not confused about it. Okay. So we have these 3 measures of average, and it seems kind of silly that we need 3 different types, but it's really because sometimes one can be a really poor representation of the population. So I'm going to kind of give you an idea or a scenario. If you see a company advertising that their average salary is $150,000 a year, and you're given a job offer for $20,000, you might think that seems like a really poor offer because, well, it's $150,000 a year, but maybe this is your first job, you have no experience, and you think that, okay, I can get my foot in the door, I have ample room to grow because my average salary or the average salary in our company is $150,000 a year. So you take that thinking that your salary is going to increase pretty quickly and you'll be making a lot of money. But if these are the salaries here, let's try to see if this makes sense to us or if this was a good decision. So you make $20K, and then looking at all of these other salaries except for Michael's, no one's making over $65,000. So this average of $150,000 is not really good for us because no employee except for Michael is making over $65,000. So this is a really poor representation for this population. So the thing is, though, this company was not lying. This average salary is $150,000. So what we're going to do, we're going to calculate the salary or the mean salary based on all of this data. So if I want to calculate the mean, again, I can call this X with a bar on top. I need to add all of these together. And just for some shorthand, instead of having to write the thousands, you can really just do the front numbers and tack on the 3 zeros at the end. So we need 20,000 plus 65,000 plus 944,000, 58,000, 52,000, 51,000, 53, 55K, and 50K. And then we're going to divide this by the number of employees, which in this case is 1, 2, 3, 4, 5, 6, 7, 8, 9 employees. So if we add all of these numbers together in the numerator, that would be 1,348,000 divided by 9 employees, which would give us, if we round out, 149.778. Okay? And again, because we're dealing, I kind of truncated all of the zeros. What that means is you'd add 3 zeros or move the decimal 3 places. This is about $149,788. And again, back here, again, we just ignored those zeros as a placeholder. Instead of saying 1,348, you can say 1,348,000. So just kind of saves you from having to write these zeros all throughout here. And you also don't have to plug it into your calculator. So again, not wrong. The average salary is around 150,000. But again, Michael is the only person that's making above 65K. So what I'm going to do instead is I'm going to go ahead and I'm going to calculate the mean salary again, but I'm going to exclude Michael. So we're going to cross this off and we're not going to worry about his salary. So if I go to calculate the mean salary, again, I don't want to have to write the thousands over and over. So we've got us making 20,000, Kevin with 65, Toby with 58, Jim with 52, Pam with 51, Creed with 53, Meredith with 55, and Stanley with 50. And this time, because I have one less piece of information, we divide it by 8. So if you add everything together in the numerator, it would be 404. And again, I'm just going to now tack the zeros back on 404,000. And then we divide this by 8. And we see that our mean in this case is 50,500. So that is much more realistic for what the average employee is making based on all of the values or salaries that we see here. So in this case, the mean is not a good representation because we have that one data value skewing it. This data value we call an outlier. It's someone that's making well above everything else. So because this mean shifted so drastically when we switch or when we got rid of it, it is not a good representation. So because of that, then your median is probably a better option, or you would use this mean when you ignored that outlier. So just try to pay attention in your general life. What's given to you, you really need to be able to dissect all the information and try to see, is there something they're not telling me? Is everything I need here to make an informed decision?